Okay, so 9b is about whether things are mutually exclusive or not. So, to tell if something is mutually exclusive, we're going to see if it is disjoint, has no overlap, or has overlap. Exclusive means they're not related, they're disjoint. So, for example, whether a card is a queen or an ace, if we look at our table of cards, our diagram of cards, we've got the queens over here and the aces over here. They do not overlap. You cannot have a card that is a queen and an ace at the same time. So those are mutually exclusive. This, which means the probability of A and B, or the intersection, like where they overlap, is nothing. There is no intersection. So there's no queen and ace at the same time. But if they have overlap, then you can have cards that are in the middle that have both characteristics. So, for example, if you have queens and hearts, then I can say, oh, okay, I've got queens, but then I also have all of these hearts. And I have this card that is an overlap, which is the queen of hearts, because those two have an intersection. And so the queen of hearts is the intersection here. So the overlap is no longer zero. It is something that I have to take away, because if I'm counting all the queens, that includes the queen of hearts. And then if I'm also counting all of the hearts, that includes the queen of hearts. So now this card has been counted twice. So I have to take it away. I'm subtracting the overlap, which is the highlighted part. So if we look at, for example, this guy, it says the key question to ask is, are there outcomes that have both characteristics? So when we're talking about rolling a die and drawing a queen, if we had the probability of rolling a 3 or, excuse me, sorry, I forgot. Okay. Or getting a queen, there is no overlap there, because the rolling a 3 has to do with dice and getting a queen has to do with cards. So the or tells me to add, and there is no overlap. I can't get a queen that is a 3. I can't roll a 3 that is a queen. So I would just do the probability of rolling a 3 plus the probability of grabbing a queen. So that's 4 out of 52 for the queen, and that's 1 out of 6 for the die. And then I'd have to get common denominators, etc., or turn them into decimals. The probability of drawing a diamond and drawing a 7, if I go back to my cards and I look at a 7, the 7s are here and the diamonds are here. I do have one overlap, and that is the 7 of diamonds, one card that overlaps. So I will come back here and I will say that it's the probability of getting a diamond. That's a terrible diamond, I'm sorry. Or probability of getting a 7. Oh, I wrote it wrong. Let's start over. The probability of drawing a diamond or a 7 is the probability of drawing a diamond plus, because the or is plus, the probability of 7. And then I will take away the probability that it's a 7 and a diamond, which is that card that's the 7 of diamonds. So the probability of a diamond is 13 out of 52, because each suit has 13 cards. Probability of a 7, there's 4 of those out of 52. And then I will take away the 7 of diamonds because it got counted twice. So again, the diamonds, there's 13 of those. There's 4 of those, but I just counted this one twice, so I had to take one away. And so that would give me 17. Since these have common denominators, I can just put them together. 17 minus 1, 16 out of 52, which I can divide both of those by 4 and get 4 out of 13. Okay, example 2 asked me to actually find this, but this one is, sorry, what this question is really asking is, are they mutually exclusive? These are mutually exclusive because there's no overlap. This one has overlap, So these are not mutually exclusive because there is an overlap. And that overlap is right there. Okay, so for example 2, asks you to find the probability, which we just did. And then example 3 says, what about a 7 or an ace? So again, you can just start by saying that's the probability of 7 plus, because the or tells you that it's plus, probability of an ace, and then minus the overlap. That reminds you to check for the overlap. And then sometimes that's just 0. So yes, 7s are here. Aces are here. They're both a column. They're both vertical. There's no overlap. So this part's just 0. Okay. So for these, it's really nice to be able to write out words for yourself. In fact, I think I wrote them out more words here. The probability of leather or black is the probability of leather plus the probability of black minus black leather. These do overlap because right here is the overlap. 4 of the sofas are black and leather at the same time. So that's what that is out of the 40. So here, writing this one out in words, the probability that a student completed their homework or got an A is the probability they completed their homework plus the probability they got an A minus the overlap. This is the overlap. In this case, we have percentage, and a raw data. So I'll turn that into percentage so that I can put them all together. So the main thing to remember here, let's look at example 6, which is a two-way frequency table. So again, writing it out in words is really helpful. Probability of female plus the probability of math minus female and math. Sometimes that overlap is 0, right? English and history, there's no overlap. Female and math, there's an overlap. And you can just try to even highlight, here's the females, all the females. Here's all the math teachers. I have an overlap right there. So that is the overlap. When you're talking about English and history, they do not have an overlap, so that part is 0. History and males, those have an overlap, and that is 7. So that is that part there. So you can always just write it like this, taking away the overlap, and then sometimes it'll be 0. So in a nutshell, the probability of A or B is going to be the probability of A plus the probability of B minus the probability of A and B. This thing is because of the or. This means A and B at the same time. Like it has the characteristics of A and B. And this thing is sometimes 0. And that is 9B in a nutshell.